All right, guys, we are going to look at the algebra type of problem associated with these circumcenter problems, okay? So you should really pay attention to this, and because you're going to have a couple of these to do in class the next time around, okay? So here we go. We're plotting 3 points to determine the triangle, and then determining, once the points are plotted, just as saying, is it acute, right, or obtuse, okay? I mean, it should be obvious. You're not doing any angle measure, but you should be obvious just by his appearance. And why I say that is because what we're looking for is to determine whether or not we should be looking for uh, the circumcenter to be inside, okay, or outside, or in the best case, if it were a right triangle, uh, the circumcenter we know would be on the midpoint of the hypotenuse. So look out for those because this can save you a lot of work, okay? That won't be the case here because we have an acute triangle. So I need to find the perpendicular bisector going through AB. I need to find the perpendicular bisector going through AC, and I need to find their point of intersection. So we've been down that road. We've done perpendicular bisectors. It's just time to look at that again, okay? So here we go. I'll just highlight this a little bit for you as we move along. Just use my pen if I need to, okay, or the highlighter, maybe that, okay? So you can't forget the coordinates. I always put them down. Don't forget the midpoint formula, okay? I've got the midpoint here, 0 comma negative 5 halves, all right? All right, 0 comma negative 5 halves, right there on the axis, kind of convenient. Slope, don't forget the slope formula, right? Every one of these steps along the way, you've got to double check because everything that you do here is going to carry on down later. So make sure you're using your calculator, get the right slope, okay? Make sure you're using your calculator to get the right midpoint. My slope is 1/4. We're talking about perpendiculars, so the slopes are the negative reciprocals there, all right? Now, okay? Now, go back, double check that, because now that information is put in to find the equation of the perpendicular bisector in here. So we do that by using the point 0, negative 5 halves, and the slope negative 4. Now, in this instance, life was made a lot easier because we have the slope and we have effectively the y-intercept right there. So that gives us the equation of the line real conveniently. Real conveniently gives us the equation of the line as illustrated right here. Okay. However, thinking ahead, we're going to need that equation in standard form because we're going to have to find its intersection with the other perpendicular bisector. So to do that, I'm going to multiply everybody by 2 and then shift the x terms over and the y so that they're together on one side. And there's the equation of the first perpendicular bisector, the bisector going through point D and at a right angle with segment AB, okay? So now we're going to do the same thing all over again, okay? It's just doing the same thing all over again. So again, we're going to find the midpoint of BC. Make sure you bring your coordinates down. Make sure you copy them down right. Make sure you use the right formula, okay, for the midpoint. X1 plus X2 over 2, Y1 plus Y2 over 2. Do your computation for your midpoint. See that it kind of makes sense on your uh, on your graph, on your picture up there. My midpoint of AC is at 1, 2. That's over 1 up 2. That looks right about there. That seems to make sense. Okay. All right. Just worth checking. Check your slope. Okay. Remember your slope formula? You did it up here earlier. Don't forget it. Always try to reduce your slope. As you can see here, I reduced my slope. Okay. I took the negative reciprocal, which is the slope of the perpendicular, which is 5/3 as indicated there, okay? Um, Now, again, I need to find the equation of the line with this slope of 5/3 going through 1, 2. All right, equation on a line through 1, 2 with the slope of 5/3. Okay, remember the process we went through with this. We didn't have to go through that process in the previous one because we had the y-intercept and the slope. So, but here we do. Okay, the point slope form calls for us saying y minus the y coordinate, which is y minus 2, over x minus the x coordinate, which is x minus 1, okay, is equal to the slope that we have. We cross multiply gives us, okay, 3y. Don't forget when you cross multiply to distribute, 3 times y minus 2 is 3y minus 6. 5 times x minus 1 is 5x minus 5. I'll put that in standard form, okay? Put that in standard form, which is as shown here. Now, okay, one step left. All right, find the point of intersection. Find the point of intersection between the line that we found in step 4 along with the line that we found in step 8. So we line these up, okay? We line them up. We see that nothing's going to cancel here. So we say, I said, well, let's see if I can cancel out the y. Cancel out the y by multiplying the top equation by -3, bottom equation by 2. That gives me a negative 24x minus 6y equals positive 15, and negative 10x plus 6y equals 2. They're added up nicely and producing the x value of negative 1/2. Throwing the x value back into any one of the original equations. I went back into here because the half times 8 would come out nicely, and I found in doing that my the y coordinate is negative 1/2 as well. So therefore, circumcenter is at negative 1/2. Okay. Seems like a lot of work, but it's nothing you hadn't already done. Okay. We're applying the principles that we looked at over here. Let's look at this very problem. Here is the triangle that we had in question. Okay. And we found the midpoints of each side. Okay, for the algebra, you only have to find the midpoints of 2 sides and the perpendicular bisectors of 2 sides. Here, sure enough, is our circumcenter, which again we remember is the center of the circumscribed triangle. The theorem telling us that the center here, the point D, the circumcenter, is equidistant. Okay, equidistant. That means, okay, the distance from D, okay, the distance from D to A, distance from D to A is the same as the distance from D to C, same as the distance from D to B, which allows me to use that as the center of the circumscribed circle. Okay, so there you have it again. All right, you'll have 4 of these problems. I'm going to post them up so you can take a preliminary look at them, go over this one, maybe make sure you can do it for yourself. Okay, not difficult, but okay, a little lengthy, a little tedious. Watch every step along the way. Make sure you have your calculator. Okay, make sure you double check every step before moving to the next step, and you should be all right. Okay, we will have some of those on the next test. Okay, and we will have a lot of vocabulary because we're talking about perpendicular bisectors, their point of concurrency, the point where they intersect being the circumcenter being the center of the circumscribed circle. The center of the circumscribed circle is inside for an acute triangle, right at the midpoint of the hypotenuse for a right triangle, and outside the triangle for the obtuse triangle. Okay, so there you have it. Review this. Make sure you can do this because that's where we're going next.